Good morning students, Vikas Global Institutions, Jangaredikudam. So last class I was discussed about in chemistry work done on the system and by the system, and explain about the expansion and compression, and also in the work done on the system, work done by the system, work done on the system, work done by the system. Work done by the system, work is equal to negative, and work done on the system, W is equal to positive. Okay, this is the last class. And also explain about the expansion and compression. We take the cylinders, it is fitted with the pistons, and it is filled with the gas molecules, Here the system by the system, here means the gas is pushed by the piston, it produces the expansion, that is called by the system, that is the work is the negative. And next one, we are applying the external pressure on the gas molecules, we get the compression, change in the volume. The work done on the system is the positive. This is the last class. Now I will discuss about the thermodynamic first law. Thermodynamics first law. So it is also known as the law of conservation of energy. The most important point, it is also known as law of conservation of energy. Law of conservation of energy. It is also known as law of conservation of energy. It gives a number of definitions about the thermodynamic first law. The thermodynamic first law ke number of definitions unnai. So it is also called law of conservation of energy. So what is the thermodynamic first law? What is the definition? What is the law? Here, energy created nor destroyed energy neither created nor destroyed, but it converts one form into another form. It form one form into another form. That is one of the definition of the thermodynamic first law. So what is thermodynamic first law? Energy neither created nor destroyed. Energy ni create cheyalam, destroy cheyalam. But it converts to one form into another form. Next one, the total amount of energy, the total amount of energy in isolated system remains constant. This is one of the law. So next one is the total amount of energy in the isolated system remains constant. Okay, Nana? And once again, so energy neither created nor destroyed, but it converts one form into another form. The total amount of energy in isolated system remains constant. Okay, Nana? Clear? Energy neither created nor destroyed, but it converts one form into another form. And next one, it is impossible to construct perpetual motion or permanent motion of mission. It is impossible to construct the permanent motion of mission which could produce energy, without consuming, which can produce work produce work without consuming energy. సో ఎనర్జీ అనేది కన్జ్యూమ్ అవ్వకుండా మిషన్ని మనం పర్ఫెక్ట్ మిషన్ మనం కన్స్ట్రక్ట్ చేయలేం. సో కంపల్సరీగా వర్క్ డన్ జరుగుతూ ఆ ఎనర్జీ అనేది కనుక కన్జ్యూమ్ జరుగుతున్నప్పుడే సో ఇట్ ఇంపాసిబుల్ టు సో వీ షుడ్ కన్స్ట్రక్ట్ ద permanent motion of the machine. These are all definitions, some ways of the thermodynamic first law. Okay, once again I will repeat it. Energy neither created nor destroyed, but it converts to one form into another form. So energy ni create cheyalem, destroy cheyalem, but energy ni oka form nunchi inkoka form loki convert cheyochu. That's the first law. And next one, the total amount of energy in the isolated system remains constant. In the isolated system lo the total amount nadu constant. That is one of the thermodynamic first law. And next one, it is impossible to construct the permanent motion of machine which could produce work without consuming energy. Energy అనేది కన్జ్యూమ్ అవ్వకుండా వర్క్ని ప్రొడ్యూస్ చేయలేం. కంపల్సరీగా ఎనర్జీ జరిగితేనే, ఫర్ ఎగ్జాంపుల్ we take the one subject, it applying some energy, it moves one place to another place, so finally we get some work. So that is the same definition in the applying in the same application. So it is impossible to construct permanent motion of machine which could produce work without consuming energy. Okay, Nana. And we have an example. We take the one example. So we take the system A. We take the one system A. It absorbs the heat energy from surroundings. So we take the one system A. It absorbs the heat energy from the surroundings. The system A converts to system B. So mathematically in the thermodynamic first law we write the delta U is equal to Q plus W. Here delta U is the change in internal energy, and Q is the, what is the Q? Heat energy, and W is the work done. Clear? So this is the thermodynamic first law, that is the delta U is equal to Q plus W. This is the thermodynamic first law. We take the system A, it absorbs some amount of heat energy from the surroundings, it converted to system B. Here the mathematically it is expressed as delta U is equal to Q plus W. Here Q is the internal energy and Q absorption of the heat energy from the surroundings by the system. So finally that is the work done is carried. So that is the thermodynamic first law. Clear, Nana? So it is the law of conservation of energy. And means conservation of energy అంటే ఎనర్జీ అనేది లాస్ అవ్వటం. ఎనర్జీ లాస్ అవ్వకుండా వర్క్ జరగకుండా పర్ఫెక్ట్ మిషన్ మనం కన్స్ట్రక్ట్ చేయలేం. అట్ ద సేమ్ టైం energy neither created nor energy create cheyalem, destroy cheyalem, but it convert to one form into another form. This is the thermodynamic first law. So next one, applications of thermodynamic first law. Applications of thermodynamic first law. Applications. Applications of first law, thermodynamic first law. We know the thermodynamic process. Thermodynamic process. What are the first one is the isothermal process. What is the isothermal process? Who is the constant in the isothermal process? In the definition in the heading lone undi isothermal process. So what is the isothermal process? Here the temperature is the constant, delta T is equal to 0. Temperature is constant. Here the U or E, internal energy, delta U, internal energy. It is a function of the temperature. Internal energy is the function of the temperature. So here also delta U is equal to 0 or delta E is equal to 0. Idena raskovachu. So what is the first law of thermodynamics? Delta U is equal to Q plus W. Delta U is equal to Q plus W. This is the thermodynamic first law. So applying in the first law of isothermal process in the first law of thermodynamics. Here what is isothermal process? In the temperature constant, the process is carried out is called isothermal process. Here the initial and final states are same. So delta T is equal to 0, means temperature is the constant. Delta T is equal to 0. Here the internal energy is the function of the temperature. So delta U is equal to 0. From the first law of thermodynamics, first law of thermodynamics, we know the first law. What is the first formula? First law, delta E is equal to Q plus W. Substitute the delta U value in the first law of thermodynamics. Delta U is equal to 0. Substitute in the formula. So delta U is equal to 0. 0 is equal to Q plus W. Q plus W. So Q is equal to Q W Q is equal to minus W at constant temperature. Qt is equal to minus W, that is the isothermal process about the first law of thermodynamics. And next one, adiabatic process. Adiabatic process. So what is adiabatic process? What is the constant in the adiabatic process? This process is carried out at constant heat energy. So at constant heat energy, that is called Q is equal to 0. Constant heat energy, Q is equal to 0. That Q is equal to substituting in the formula first law. So we know the first formula, that is the delta U is equal to Q plus W. Delta U is equal to Q plus W. Substitute the value in the first law. What is the value? Q is equal to 0. So delta U is equal to Q0 plus W. So delta U is equal to W. At constant heat energy. That is the adiabatic process. What is adiabatic process? The process is carried out in the presence of at constant heat energy. So Q is equal to 0. Substitute the value in the first law of thermodynamics. So delta U is equal to Q plus W. So delta U is equal to W. This is the adiabatic process. And next one, isochoric process. Third one, isochoric process. What is the isochoric process? What is the constant? Here the volume is the constant. So delta V is equal to 0. Volume constant. So delta V is equal to 0. We know the work, that is W is equal to minus P delta V. We know the formula, work done, that is W is equal to minus P delta V. Substitute the value delta V value in the formula, that is W is equal to minus P delta V. So W is equal to minus P into 0. So work is 0. Work is equal to 0 at constant volume. That is the work done. W is equal to minus P delta V. So W is equal to 0. That value, that W value substitute in the first law of thermodynamics. That is the first law of thermodynamics is delta E is equal to Q plus W. You get the delta U is equal to 0. Q plus W. We get the delta U is equal to W is equal to 0. W is equal to 0. So delta U is equal to Q V at constant V. This is the isochoric process. Clear? And next one, fourth one, isobaric process. So what is isobaric process? Who is the constant in the isobaric process? Pressure is the constant. Here pressure is the constant. So delta P is equal to 0. So we know the work done, that is the W is equal to minus P delta V. Okay. So we know the first law of thermodynamics, that is the delta U is equal to Q plus W. The W value substitute in the first law. W value substitute in the first law of thermodynamics, that is the delta U is equal to Q plus W. ఇందులో సబ్స్టిట్యూట్ చేయండి ఏమవుతున్నప్పుడు. సో డెల్టా U is delta U is equal to Q, W is the minus P delta V minus P delta V. So here what is the delta U? There is a change in the internal energy. Here delta V is the change in the volume. So U2 minus U1. Delta U is the U2 minus U1 equal to Q is minus P into delta V means V2 minus V1. V2 minus V1. So U2 minus U1 is equal to Q minus P V2. లోపలికి మల్టిప్లై చేస్తున్నాను. Multiplied with the P, that V2 and V1. So Q minus P V2 minus into minus plus, so P V1. Okay, and next one, these two values wherever are two values minus P V2 plus P1, ఇవి రెండింటిని లెఫ్ట్ తీసుకొస్తాను. సో ఏమవుతుంది చూడండి, U2 minus U1 మైనస్ ఇటు వైపుకి వస్తే P V2. ఓకే, అండ్ ప్లస్ ఇటు వైపుకి వస్తే మైనస్ P V1 ఈక్వల్ టు Q. ఓకే, సో ఏమవుతున్నప్పుడు U2 ఇక్కడ వస్తున్నాను, P V2 రాస్తున్నాను చూడండి, U2 ప్లస్ P V2. ఓకే, మైనస్ U1 మైనస్ P V1 ఈక్వల్ టు Q. ఓకే, అండ్ నెక్స్ట్ వన్, సో ఏమవుతుంది చూడండి అన్న, U2 ప్లస్ PV2 ఈ రెండిట్లో మైనస్ కామన్ తీస్తున్నాను, మైనస్ ఆఫ్ U1 మైనస్ ఆర్ ప్లస్, హియర్ మైనస్ ఉంది ఇక్కడ నన్ను, సో మైనస్ ఆల్రెడీ కామన్ తీసాను, సో ప్లస్ PV1 U1 plus PV1 equal to Q. Okay, so we know the enthalpy. What is enthalpy? H is equal to U plus PV. Enthalpy H is equal to U plus PV. So we write the H1, H2. H1 is equal to U1 plus PV1. H2 is equal to U2 plus PV2. The two values substituted in the formula. So U2 plus PV2 that is equal to H2 minus U2 plus PV1 H1 equal to Q. So change in the enthalpy. So that is right, the delta H is equal to Q at constant pressure. This is the isobaric process. Clear Nana? Once again, here the isobaric process, pressure is the constant. So delta P is equal to 0. So W is equal to minus P delta V. That is the work done. So delta P, we know the first law of thermodynamics, that is the delta U is equal to Q plus W. So delta U is equal to Q minus, means work is the minus P delta V. So Q minus W badalu P dV substitute chesanu. So Q minus P dV. Okay, and next one, U2 minus U1 is equal to Q minus of the delta U is internal energy, change in the internal energy. So we write the U2 minus U1, delta V is change in the volume, we write the V2 minus V1. So minus of P into V2 minus V1. Okay, and U2 minus U1 is equal to Q minus of, so minus P ni lopaki multiply chestunanu, minus PV2 minus of minus plus PV1. Okay, we write the two values P1 PV2 left తీసుకొస్తున్నాను. So U2 minus U1 plus minus వైపుకి వస్తే ప్లస్ అవుతుంది, సో ప్లస్ PV2 minus PV1 equal to Q. Okay, we add the two values U2 plus PV2, the 2 1 the values, two values are add చేస్తున్నాను. So U2 plus PV2 minus U1 minus P1 equal to Q. So U2 plus PV2 ఇక్కడ ఏం చేస్తాను, మైనస్ కామన్ చేస్తున్నాను, U2 plus PV2 minus of U1 plus PV1 that equal to Q. Here the enthalpy, we know the enthalphy already last class చెప్పుకున్నాం, that is H is equal to U plus PV. So what is the enthalpy? Next one చూసుకున్నాం. So write the H1 H2. H1 is the U1 plus PV1, H2 is equal to U2 plus PV2. So H2 minus H1 is equal to Q. How we get the H2? U2 plus PV2 is equal to H2, U1 plus PV1 is equal to H1. So H2 minus H1 equal to Q. That is the H2 minus H1 means change in the enthalpy. So we write the delta H is equal to Q at constant pressure. Okay, and last one, cyclic process. So what is the cyclic process? We take the system A. We take the system A, it converted into B, B is converted into C, C is converted into D, finally we get the A. This is the cyclic process. That is a cyclic process. Initial step, regain after some operations, we get the A, initial system, we get the so many operations, we get the initial system. ఏదైతే తీసుకున్నామో అది రిపీట్ అవుతూ మళ్ళీ వస్తుంది. సో దట్ ఇస్ కాల్డ్ సైక్లిక్ ప్రాసెస్. ఇన్ ద సైక్లిక్ ప్రాసెస్ we know the delta U is equal to 0. You know the formula delta U is equal to Q plus W. So we get the delta is equal to 0. So U is equal to 0 equal to Q plus W. Q is equal to minus W. P equal to minus W. This is the cyclic process. So this is the total thermodynamics first law and applications of first law. So once again I will repeat it. What is the thermodynamics first law? It is a law of 5 minutes to complete chestana. So it is a law of conservation of energy. We have some ways in the thermodynamics first law. So one is the energy created, energy neither created nor destroyed, but it converts from one form to another form. The total energy of the isolated system remains constant. The total energy of the isolated system remains constant. Impossible to construct the absolute, means permanent motion of the machine which could work, which could produce work without consuming energy. Energy అనేది కన్జ్యూమ్ అవ్వకుండా వర్క్ అనేది జరగదు. వర్క్ అనేది జరగకుండా మిషన్ మనం కన్స్ట్రక్ట్ చేయలేం. సో దట్ ఈస్ ద thermodynamics first law. It is the law of conservation of energy. Energy neither created nor destroyed, okay, but it converts one form into another form. The total amount of energy of system, isolated system, okay, the total amount of isolated system remains constant. And third one, ipude cheptunnam entadi that it is impossible to construct the permanent motion of the machine which could produce work without consuming energy. The three definitions along with the thermodynamics first law. It is a law of conservation of energy. So what is the mathematical expression? That is a delta U is equal to Q plus W. This is the thermodynamics first law. Some applications of the thermodynamics first law. So we know these are all applications already we know. So what are the thermodynamic process? That is the isothermal process, adiabatic process, isochoric process, isobaric process and cyclic process. Okay, in the isothermal process temperature is the constant, delta T is equal to 0. Here the internal energy is delta U is internal energy is a function of the temperature. So delta U is equal to 0. The delta U is equal to substitute in the formula of the thermodynamics first law. So delta U is equal to Q plus W, delta U is equal to 0, that is the Q plus W. We write the at constant temperature of the heat, that is the QT is equal to minus W. This is the isothermal process. And next one, adiabatic process. So what is adiabatic process? At constant heat energy, that is the Q is equal to 0. Substitute in the formula, that is Q is equal to 0 in the thermodynamics first law. So delta U is equal to Q plus W. So delta U is equal to 0 plus W, delta U is equal to W at constant heat energy, that is the adiabatic process. Next one, isochoric process. Here volume is the constant. So delta V is equal to 0. We know the work done, W is equal to minus P delta V. So W is equal to delta V is equal to 0. Finally we get the W is equal to 0. The W is equal to 0 value substitute in the thermodynamics first law. So delta U is equal to Q plus W. So W is equal to 0, delta U is equal to Q plus 0. So delta U is equal to QV at constant volume of the heat energy is equal to internal energy. Internal energy. And isobaric process. Here in the isobaric process, pressure is the constant. So delta P is equal to 0. We know the work done, W is equal to minus P delta V. The W value substitute in the first law of thermodynamics. So delta U is equal to Q plus W, W is equal to minus P delta V. So delta U is equal to Q minus P dV. Here delta U is the change in internal energy and delta V is the volume and change in the volume. So we write that U2 minus U1 is equal to Q minus P into V2 minus V1. So U2 minus U1 equal to Q into substitute in the multiplied with the minus P V2 V1. So Q minus P V2 plus minus of minus plus P V1. So U2 minus U1, the two values P1 P2 left తీసుకొస్తున్నాను. U2 minus U1 plus PV2 minus PV1 equal to Q. So the two values are add u2 plus pv2 minus u1 minus pv1 equal to q. So u2 plus pv2, here the 2 రెండిట్లో నుంచి మైనస్ కామన్ చేస్తున్నాను, u2 plus pv2 minus of u1 plus pv1 equal to q. So h is equal to u plus pv. That is we know the enthalpy, that is h is equal to u plus pv. h1, we write the h1 h2, h1 is the u1 plus pv1, h2 is equal to u2 plus pv2. So h2 minus h1, so u2 plus pv2 is equal to h2 and u1 plus pv1 is equal to h1, h2 minus h1 is equal to q. So finally we will it is the h2 minus h1 is the change in the enthalpy. So h2 minus h1 is equal to delta h. So delta h is equal to h2 minus h1. So delta h is equal to qp at constant pressure. And last one, cyclic process. In the cyclic process, delta E is equal to 0. So thermodynamic first delta is equal to q plus w. Substitute the delta U value in the first law of thermodynamics. So 0 is equal to q plus w. Q is equal to minus w. Okay, this is the thermodynamic first law and applications of thermodynamic first law. So this is the today class. Tomorrow I will continue. Thank you, students.